So, last talk of the day. So, no one has dinner plans, right? No, I'm kidding. So, thank you very much for being here. And I'm also very thankful for the organizers for inviting me. Before I start my talk, totally spontaneous. Before I start my talk, I want to ask you something. Who has heard about this paradigm before? Fresh body, fit mind. Good. Okay, so what this means is that in order for your brain to function, get all those brain juices and blood into your brain, which of course allows you to focus more on my talk, means that you need to move. You're supposed to exercise. Now, given the fact that you've been fed and you've been sit here all day, and me being a water polo coach, we're going to exercise. So, please stand up. People who were on their phones are like, what? Wait. Who has seen any of my talks before? No one. Gets better and better. Okay, because you don't know what's going to happen next. Okay, so the exercise is going to be very, very simple. Okay, I will show you my back so you can follow exactly what I'm going to be doing. Okay, so what you need to do is raise up your arm so that your elbow is in line with your eyes, like both of them. Yeah, I'm watching. Okay, now open up your palms, both of them. Okay, and put them together repeatedly, very fast. Thank you. So comedy is over. Now we talk about the serious. No, that's it. You can go. You can leave now. Right. So what I do is I collect these pictures. Okay. I go to my boss, and then I show him, and he's like, "What did you talk about again that you got a standing ovation?" So if you want guaranteed promotion, I mean, I'm a director now. I can like a senior director next week. So promotions, pay rises. Just show these pictures. Easy. Okay, so let's be serious now. Okay? So I love comedy, by the way, but that's not what I am here for. So we're going to talk about images, image performance, image optimization, that kind of stuff. And I'm going to start this talk by sharing a couple of statistics with you. First of all, there's a very good resource, which if you're not familiar with, then please check it out. It's called the Web Almanac. Once you get access to the slides, the links to that would be on the bottom right-hand corner. Do not disturb on. Okay. So one very important statistic is that, and this is from the media report, and again, just very briefly, the Web Almanac is a project run by Google. And what you can do is essentially, or what it does, it analyzes data for every year, and then there are chapters or reports about the data that they find. Now, there's one chapter for JavaScript, one for HTML, CSS, accessibility, that 20 plus chapters, and chapter 6, 7, or 8 is about media. So they analyze anything related to media on the web for a given year. So this number comes from the 2022 report, and it said that 99.9% of the pages out there, which are being analyzed, make at least one request for an image resource. So that tells me that pretty much every website that you visit today will have an image of some sort. And then here's another interesting report. So I do work for Cloudinary, so we're an image CDN, if you want to call us that. We do a lot more than that, but let's simplify things. We also came out with a report, and in 2022, Cloudinary handled 199 billion image requests per month. Okay, that's a lot of image stuff on the internet. Okay, that's a lot of images going back and forth and being served and requested. Now, the next slide, before I bring it up, it's a little bit about diversity, right? So usually, as web developers, we're thinking, laptop, PC, etc., or mobile devices, iPads, iPhones, tablets, so on and so forth. Interesting enough, what Cloudinary found is that there were 2.7 million image requests per month requested by Sony Bravia TVs. FYI, optimized for Sony Bravia TVs as well, please. Now, why is this important? And the title of this talk is, a picture is worth 1,000 kilobytes, but the saying, a picture is worth 1,000 words, right? Because looking at an image, you can convey a message much easier than explaining it in words, okay? And that is because, again, there's a link, about 50% of our brain, or parts of our brain, is concerned about processing visual stuff, okay? So our brain is also kind of wired to understand images and read information off from images. So why is this important? It's important because we use a lot of images on the web, and we want to be sure that those images load fast so that they can convey the intended message to our end users. I don't know how many of you know Andri Helvetica. If you do not, then please follow him. Amazing guy. He shares a lot of stuff about web performance. And he said this in 2021, that the image element turns 25 in 2020, and it both engages users with delight and enrages developers. And I think it's a very, very good a summary of the image element, because as users, we love looking at images, and when we buy something on e-commerce, we like to explore it, zoom in, etc. But as developers, getting images in front of our users can be a frustrating experience. Okay, and I'll tell you why that is. Now, what I've done, I went back to the HTML spec in 1995, and I looked at the image element, how it used to be. Now, some of you in 1995 may have been not even born, I don't know, but there was this thing, right, the image element, that had 4 attributes: align, alt, ismap, source. Simple, right? You put an image element, you added a source, here's the source usually for my JPEG, done, move on, okay? So today, this is how it looks like, okay? So source, alt, width, height, source set, sizes, loading, decoding, style, yada, yada, yada. So you can add a lot more to the image element. Now we're going to analyze some of these because I want to share very important things about these attributes, but do realize that the image element is very, very powerful. It can do a lot today in 2023. Sorry, it's not 2022 anymore, is it? So image optimization itself is easy, at least you think, but getting it right is going to be very difficult, or at least I'm going to show you why it's difficult. So the things that you need to think about are formats, content, what are the devices, Sony Bravia TVs that you're targeting. Do you want to do responsive design, and do you want to have responsive images? How are you going to deliver those images? How those images should be decoded by the browser, eagerly, lazily, etc., etc. So there's a lot of things to unpack when it comes to image optimization. Now the good news is that there are a variety of tools at your disposal. So there are online tools like Scoosh, and by the way, Scoosh now also has an NPM package, so you can run that through the CLI. There are other tools like Sharp and GIMP that you can access through NPM to do image optimization. There are desktop clients like ImageOptim that do that, and there are, of course, a myriad of image CDNs that help you with image optimization. So the tooling is fine, but you still need to understand what you're doing. And some of the key things, and I'm not going to focus on all of these because then it would be a really long talk, but some of the things that we're going to focus on are image formats. AVIF, WebP, JPEG, PNG, how are those different? User devices, so you need to consider device pixel ratio, viewports, art directions. Then, of course, there's a very, very big thing and a very hot topic these days, which is Core Web Vitals. Who's worried about Core Web Vitals? There should be more, and I'll tell you why. So there's Core Web Vitals, there's responsive images, there's placeholder images, various loading techniques for that. So we're going to unpack some of these, hopefully, in this talk. So again, there's a link for this particular graphic. We call this the image format battle card. It's a much larger piece of document. In here, what we've done within Cloudinary is we try to sort of categorize or list the image formats that are out there and available on the web, and see if they are good at producing low fidelity images, high fidelity images. What is the compression rate? Can it produce lossy or lossless encodings? And then we kind of highlighted how well they do in each category. But some of the important things is that JPEG, which is I think I have a slide on that, is the most widely used image format out there today. But it's from 1992. It's old. It's not the most optimal one, right? Then you have AVIF, which is relatively new, but it also has some cons, which I'll tell you what they are. Even though AVIFs are generally speaking very much smaller than JPEGs, but you need to be aware of a couple of quirks with AVIF. And here's this, referencing the Web Almanac report again. This chart shows you, this pie chart shows you the most used image format on the web in 2022. And of course, there's JPEG, there's PNG, there's GIF, there's WebP, SVGs, and some others. I'm not going to specifically talk about this, but do not put GIFs on websites. Just don't, okay? GIFs are heavy resources. They are megabytes. Don't load megabytes worth of GIFs, please. If you really want to have animated content, let's just take a sidetrack here. And that's not why I came here, by the way. But anyway, so GIFs, right? If you want to use GIFs, convert it to an MP4 or to a WebM, even better. Put it into a video element, add the muted loop autoplay attributes, and it will be a GIF, okay? But the size is going to be a fraction of the original GIF. So do that. Back to the topic. So on this, in this video, hopefully it's, I think I need to press a button to start, but what you will see, and it's going to be slowed down, is I'm going to, so I wrote this tool where I take one image, then based on the selection that you pick on top, I'm going to slice that image into 3 pieces and load the first part of the image as WebP, then the second part as AVIF, and the third one as a progressive JPEG. And what you will see is that the sort of next-gen formats, WebP and AVIF, because they were derived from video codecs, they can't really do progressive loading. So even though you will see, I think, the AVIF to appear first, then the WebP, then the progressive JPEG, you won't see anything in the AVIF and the WebP columns. It's just going to be blank. And in that time, the JPEG will start to load something. Now, you need to understand this because what is that you want to achieve? Do you want to load something really fast? Or do you want to show your users something and then allow progressive JPEG? Progressive JPEG is, by the way, a JPEG where, and I'm sure you've seen this before, something blurry loads and then kind of layer by layer, it becomes more and more, it becomes sharper. Okay, but a lot of people, right? So we have the JPEG, it's there, and then AVIF, boom, out of nowhere, just load it. Of course, it's going to win, and then WebP is going to be the next one, and I'm changing it to PNG. Generally speaking, PNG is going to be really slow, as you can see. But right, AVIF in the very, in the first part of the video, you saw that there was nothing. The JPEG started to load. They all, make the request at the same time. And then the AVIF just boom, just load it. Okay, so let's play that again. Right, there's nothing in the AVIF, but then boom, it's just there. Now, is this what you want? Fine, go with it, but do understand the sort of limitation. Another thing, and that's very important to understand, especially when you do image optimization, is fidelity. So a fidelity of the image pretty much means that, or fidelity in general means that you try to preserve the details of the original image as closely as possible. Okay, so what I mean by that is if you have an image and you want to optimize that and you want to create a high fidelity optimized image, it means that you need to reserve, for example, the patterns. If it's a t-shirt, the fine details of the material needs to be preserved. Now, some image formats by default create low fidelity images. So what that means is that here's the same image. On the left, you see what I refer to as a low fidelity AVIF. And on the right, you see a high fidelity JPEG. Now, I don't know how well that's going to come across the big screens, but the low fidelity AVIF, I'm not even sharing that data, but it's going to be a fraction of the size of the JPEG, which means that it's going to load faster, it's going to be better, but it's low fidelity. And what that means is that you're losing the fine detail. Again, I don't know how, is that visible? There's supposed to be like a brick pattern on the JPEG, which is completely gone on the AVIF. So on the AVIF, it seems it's like a red, smooth wall, as opposed to, you seeing the sort of brick structure. Okay, and that's important because you now lost the fine detail. If you're okay with it, good. But if you're not, you need to understand that it happens. There was this Xerox incident. I don't know how many of you heard of this. This is maybe 10, 15, 20 years ago. So the incident is not related to the web, I'm just going to tell you anyway. So the Xerox scanners had an encoder which produced low fidelity images. So what you see on the left is what got scanned, and what you see on the right is the output of the scanner. Okay? Low fidelity in action. Now, that's how you either make or lose money. So this was a big, big incident. This happened in either Switzerland or Germany or Austria, one of these German places, or German-speaking places, whatever. And then they had to fix it, right? So, they now, Xerox now use different image encoders for scanning, but this was a very, very big scandal because, well, obviously, you scan something, you get different numbers, and then you pass those numbers to your clients and customers and tax authorities, and you're going to get into trouble. So, what does this all mean? So let's think about a totally legit e-commerce company that I made up. So, let's say that you're a developer there, and your boss says, we need to provide better experience to our users, which means, I want the site to load fast and it should be snappy and stuff. And you're like, okay, so I know that AVIF exists, so I'm going to just, encode all these images into an AVIF format. It's going to lower the bandwidth, so you're going to save money. It's going to, appeal to your users because the images will load faster because they are smaller. So that's great. So great browser experience, you get better sales, better profit, etc. Until, what was that? Did you hear that? Okay. So until your clients will receive the actual products, and they will realize that the colors don't really match what they saw on the website. The pattern of the fine detail is not exactly how they envisioned it, and they start to return the stuff because that's not really what I saw on the website, right? Now I have an example again. I kind of know that this is not going to be visible, but this is an unknown brand's website. So the image, some guys are like, whatever. Girls are like, whoo. This is the original image, right? So this is a JPEG, and what I will do, this is a video again. So I took that JPEG and I created an AVIF from it. And what you should theoretically see is that the color of the bag is going to change. It's going to no longer be black, but it's going to be some darkish green, and it's going to lose all the pattern. Now I'm going to play it. I don't know if that's probably not visible at all. It's visible on my machine. I'll show it to you later. But the point is, if you produce an AVIF, even the color changes. It's no longer going to be that dark black, but instead it's going to be this very dark green. Again, you're showing something different to your users, okay? The image itself is going to be much smaller, yes. It's going to load faster, yes. But it will look different, okay? So just be aware of that as well. So, core web vitals. So for those of you who are not worried about core web vitals at all, I'll make you worried now. So, who knows core web vitals? Okay, so for those of you who don't know core web vitals and you happen to work in a website that is, well, on a web page of any sort, just know that core web vitals, or scoring well in these core web vitals, also impact your search page ranking. Okay, so if you if you fail some of these, fail the criteria for some of these core web vitals, Google is going to penalize your search page ranking. Okay, so scoring well in these three categories for core web vitals means that your search page ranking will also go up. Okay, and that's why it's really important, and that's why a lot of people started to talk about this. There are three core web vitals today, a fourth one coming. So there's first input delay, cumulative layout shift, and largest contentful paint. The fourth one is INP, which is interaction to next paint. Someone's not, okay, yeah. And they said it may actually replace first input delay. It may be a fourth one. We'll see about that. So that IMP is experimental today. I'm not going to focus on first input delay, but I'm going to, and nor on cumulative layout shift, but instead I'm going to focus on largest contentful paint. So what is largest contentful paint? Largest contentful paint essentially measures how long the largest element on the page took to load. Now, usually in modern UX practices, the largest element is an image of some sort, a hero image or an image of a product or something, right? And actually, in order for you to optimize the largest contentful paint, you need to optimize, or you need to do 4 sub-optimizations, okay? Those are optimize time to first byte, optimize resource load delay, optimize resource load time, and then reduce the element render delay, Okay, so these four things, these four sort of components that make up the overall largest Contentful page score. What I don't have on the slide, because I forgot to put it there, is the scale. So if the largest element on the page loads between 0 to 2.5 seconds, you're good. 2.5 to 4 seconds is caution, warning, orange. And then 4 seconds and above, you're going to be penalized. You definitely need to fix that. Okay, so essentially what we're saying is that the largest element on the page in the, in the viewport, so it needs to be, visible on the first load, has to load between 0 or 0.1 to 2.5 milliseconds. Okay? Milliseconds. 2.5 milliseconds. 2.5 seconds, of course. Okay? So let's go through some of these sub-optimizations, right? So time to first byte, right? Time to first byte basically measures the time between you making the request and the very first byte of that resource arriving to the page. So the goal is that you need to optimize that time. Now, this is not really related to image performance. I'm not going to talk about it a lot, but things like, server-side rendering versus building your site statically at build time, right? Server-side rendering will extend your time to first byte. So you need to make sure that you try to avoid server-side rendering in order to get a better LCP score. Then we have resource load delay. Resource load delay is basically the delta between the time to first byte and the browser finding the LCP candidate and starting to load that, okay? Now, generally speaking, what you need to do is start to load the LCP resource as soon as possible. Ideally, it should be the second or the third request that your browser loads. Anything later than that is probably already too late, okay? Now, how can you do that? One suggested way from Google, and this is, obviously doesn't have a big browser support, but there are some alternative ways, but this is the recommended way, is to set the fetch priority attribute on a link element to high and on a preload for a given image. So if you add this to your HTML, the browser will start to download this particular image as soon as possible. It's usually going to be the second request after the HTML, right? And that's what you want. You want the browser to find the LCP candidate as soon as possible. Then you have the resource load time, and this is where image optimization comes into play, because resource load time means, or resource load time measures the actual time it takes for the resource to arrive, which is the time it takes for the resource to be transferred over the network. The larger the file is, the more time it's going to take to arrive. So what you want to do, you want to make sure that you have smaller sizes, right? Optimized image resources. So what can you do? Well, send smaller resources and do image optimization. Now, I have an asterisk there next to loading images via CDN. I'll tell you why that is there in just a second, but one sort of side note that I want to, and it's not side note, it's side node, I'm sorry. So one side note that I want to say is, if the LCP candidate is not an image, but if it's text, then the time it takes for you to load and apply the fonts also matters, okay? So that's just on the side. So why is there an asterisk? So, of course, loading an image resource from the same domain is, generally speaking, going to be faster than loading it from a CDN, right? Because if you load it from a CDN, you have to, make all these network requests, DNS lookups, etc., to the actual CDN's website and then receive the resource. But on the other hand, an image CDN could have additional functionality or additional benefits, right? For example, automatic image optimization, automatic format selection. So you need to decide whether you want to, whether you want to opt in for that and use the additional benefits, or you do the optimization on your own and serve the LCP candidate locally. But what matters is that you optimize that, whatever that resource is. It doesn't matter if you optimize it to the CDN or you optimize that locally. And then the last point, element render delay. So the element render delay is a delta between when the LCP candidate, let's say the image, has arrived to the browser and the browser's capability to display that image for you. Okay, so that's the time in between the two. Which brings up, don't even read what's on the slide, just remember this one simple rule. Do not, you should repeat this, do not lazy load the LCP image, please. Okay? Now, funnily enough, you go to Shopify, they just say, yeah, lazy load everything. It's it's just how it is. WordPress plugins, they lazy load everything. Don't lazy load the LCP image. Try to find ways around this. There are actual articles about, how you can disable lazy loading for your LCP candidate for WordPress plugins and for Shopify and for other places. Why is that? If you lazy load something, then you're going to prolong the LCP time. You prolong the LCP calculation, okay? So do not apply lazy loading. The other important thing is don't load the LCP image from JavaScript, okay? Why? Because the browser would have to download the JavaScript as well, has to parse it, has to execute it, then it will find your LCP, then it will inject it to the DOM, for example. So all of that work is, again, going to prolong your LCP time. So, nice. You thought that was over, right? Not yet. So, how can you, what are the tools that you have to see, what is my LCP? How is my performance looking? So there are lots of tools within the browser. So hopefully a lot of you are familiar with Lighthouse. It's built into DevTools. It runs tests against images as well. It tells you whether you're using next-gen image formats, whether your images are loaded efficiently, whether they are loaded lazily or not. So that's good. And it will also tell you some of the core web vital scores that you get, including the LCP. Now, I'm going to say that it is good, it's great, use it for development, but do not rely on Lighthouse data for assessing your website's performance, especially for core web vitals. Why? Tell us why. Okay. So, good question. So, Lighthouse runs on your machine. Okay, so if we all open up the same website, we run a Lighthouse report on that website, we're all going to get different results. Okay, because we have different, network connections, different devices, different memory, CPU, different configurations for our machines, different setups, etc. So what you should rely on is data from PageSpeed Insights. There are other tools that measure what I'm going to share with you in a minute, but PageSpeed Insights, the reason why I say that is because the output will look exactly the same as Lighthouse, except the very first thing that you will see on PageSpeed Insights is what is called RUM data, real user metric data. So what you will see is an aggregate from all your users visiting the site from the past 28 days. If you're in the green for core web vitals, let's say LCP is 1.2 seconds, it tells you that at least 75% of your visitors in the past 28 days had a good LCP score, had a good experience. If you are in the red or in the orange, it means that you are providing a bad experience for your users. And that is the data that you should be looking at. There are other tools like Trio.sh, Yellow Labs, Debug Bear. There are others that also use RUM data, real user metric data, to make these assessments. And that's what you should look at. I don't know how many of you have seen the, I think it's available since Chrome 102, 3-ish. There's a new panel in DevTools called Performance Insights. Performance Insights, and let me just, you can't really see it, but sorry. So that's what you see is 3 screenshots, right? The 2 big ones are from Lighthouse, and it says, largest contentful paid image was lazy loaded. Image elements don't have width and height, and please serve images in next-gen formats. So try to actually do that, because that's going to help you. But more importantly, if you run a report using the Performance Insights panel, which is still in experimental, you will get this, and then you unfortunately can't see that, but at the very bottom, it actually tells you the timing breakdown for your LCP. So on the top, you see a red number, 7.51. It means that's your LCP score. And in the very bottom, hopefully you see, those kind of bar charts. Those are the 4 breakdowns that I mentioned. So it actually tells you how long was your time to first byte, how long was your resource load delay, et cetera, et cetera, et cetera. So now you can see that, okay, in this particular case, the resource load delay was 600 and whatever milliseconds, but the resource load time was 6 seconds. So you know that, okay, resource load time is the bit that I need to focus on, because if you reduce that, your overall LCP result will also go down. Okay, so this is in the Performance Insights panel, which is available in, as an experimental feature in the latest versions of Chrome. So that's a lot, right? That's a lot of things to think about and do that. Question is, can you do this all in once? Yes, you can. So there are many ways that you can achieve image optimization, and because I don't have a lot of time, I'm just going to focus on, here, this one. So what you have here, and I'm more than happy to show this as a demo if you're interested, but I don't want to do it right now. So what I have here is I uploaded a picture to Cloudinary, right? And then the first URL is, you upload an image, you get an access URL to that image, you put that in your browser, and then it will say, yeah, that's a JPEG, and it's 583 kilobytes in size. Then I'm just adding Q_auto to that particular image, okay? Just adding that reduces the size to 50.4 kilobytes. Q_auto is short for automatic quality. So what happens is Cloudinary is going to look at the image, and it's going to remove everything from the image, metadata, whatever, that is not needed for the image to be displayed. And it does it in a way that you won't see any visual artifacts or defects. It's not going to introduce color bleeds, pixelation, etc. So it's not going to be visible to the human eye, but still you can see from 583 we went to 50 kilobytes. And there's no change in width or any of the dimensions of the image. Then I added fauto, which is short for automatic format. And why I added fauto is because now if you take that same URL and you open it from Chrome or from Safari or from Firefox, we look at the requesting browser, and we're going to send an image format that is one of the next-gen image formats that is supported by the browser. Okay, so if you open up that link, say in Safari, that doesn't support AVIF, it's going to send a JPEG 2000, or it's going to send a WebP, because latest versions of Safari do support WebP. But if you open it in a browser that supports AVIF, we're going to send an AVIF. So we just with Q_auto fauto, we go from 583 to 18.4. And what's also important to understand is these optimizations happen at the server side, so it happens at Cloudinary side, and it happens uniquely for every single image. So it's not that, with an optimization tool, you say, okay, here I have 100 images, produce a quality reduced, Q75 WebP, and it's just going to do that for all of those images, right? Because some images can do with more quality reduction, some can do with less. So Q_auto takes care of that. Okay, need to wrap up. So a couple of tricks and tips before I finish. Which one? Okay, so this is a trick that you can use, which is a low quality image placeholders, or LQIPs that we call them. What you can do, you can actually load a lower quality version of the image and have it replaced with the high quality version. Now, don't do this for LCP, okay? But for non-LCP images, you can preload something that's only 2.8 kilobytes, show your users that, hey, there's going to be something, show the silhouette, and then once everything else is loaded on the page, then you can load the final image. And you can very easily do this with JavaScript. There are lots of techniques to do this, and I'm happy to talk to you about that as well. One more interesting thing. So if you happen to do image optimization on your own, for whatever perverse or the reason you want to do that, you should create at least an AVIF and a WebP, right? Because those are the next-gen formats. If you do so, you can use the picture element with source elements. So in this case, the browser will pick the format that it understands, and it will load that, right? So with this, also note that your fallback, which is the image element, should always be a JPEG, because every single browser out there understands that. Two things to note. One, the order of the source matters, or the source elements matters, okay? If you would put a JPEG in the first line as the source, and then a WebP next, what's going to happen? The browser will always download the JPEG and then ignore the rest, okay? So get the order right, which should be smallest file, second biggest file, fallback to usually JPEG. The other thing to note is that I have the loading, lazy, and decoding async attributes added to the image element. Just know that if you do that, it would also automatically apply to the source elements. Okay, so you can't specify loading lazy on the source, but if you specify it on the image element, it means that if I open up this code in the browser that supports AVIF, the loading lazy and decoding async attributes will apply to the AVIF as well. Okay, and to all the source elements. Okay, one more thing. This is why you paid the ticket. Okay, trust me, you will thank me later. So let me show you the example that triggers this. Hopefully that's visible. So on here, is it this one? No, it's this one. So source sets, right? So very, very briefly, right? In source sets, in combination with sizes, what I'm saying here is that if the browser's width is 0 to 600 pixels, then load the image that is 400 width. So you see the first source set has a W400, which pretty much means that Cloudinary generates a 400 pixel image on the server side and it will serve that. And if the sizes attribute, so if my media query is, if the browser width is larger than 600 pixels, then I want to load an image which is 400 pixels. So I want to load something that's, larger and then, it has more detail, etc., etc. So I added this source set, sizes, and I started to test it. So how do you test it? You go to DevTools, you click the little mobile whatever icon that allows you to sort of drag your screen, and it shows you how the pixel, the width of the viewport, right? And then even at like 200 pixels, it loaded the 800 width image. And no matter what I did, it always loaded the 800 width image. Why? And I spent half day, like people in the office were laughing at me because I was sitting there. I was like, I can't see it. I don't know. I give up. Now, so this is the view, right? So when you open up this view, you will never notice the 3 dots. And when you click those 3 dots, there's this setting called Add Device Pixel Ratio. So device pixel ratio means that on devices like this wonderful piece of artwork, the HTML tries to load twice as many pixels. Okay, so this is Retina screen. Other vendors call it differently, but what happens by default? They try to load twice as many pixels, i.e., the device pixel ratio is 2.0. And when you go to that 3-dot menu, you select Add Device Pixel Ratio. Then out of by magic, the drop-down will appear, which I highlight on the right-hand side, and it defaults to 2.0. So 400 times 2 is 800. So no matter what I did, it just always loaded the 800 pixel version of the image. So FYI, if you ever want to test something like this, select 1.0 from the drop-down, which is not the default, okay? And then test it. And once you do that, it will load 400 pixels, and so it will actually adhere the actual media query rule, okay? Half a day. So I'm giving this to you in a minute, so you're welcome. Doesn't matter. Okay, so usually people ask me this question like, hey, you talk about all these images and image sizes and image performance. We know it's not happening out there. Yes, it does. Unnamed, well-known luxury Swiss watch brand's website. Okay? If you come to me, I'll tell you which watch brand is it, but I think I masked it out everywhere because I love watches and I don't want to shame them. Very big company. I was at a watch convention. They had a big booth. They are there. They're everywhere. So you see those little images, the 5 novelties. Each image is about 2 megabytes. Okay, the small ones. When you actually go to the product description page, that's when things get like 10 megabytes, 12 megabytes, okay? So it's there, it's a real problem, right? I don't know why they are doing this, but what they do is they take an image that's 1,250 by 1670 pixels and they shrink it down to 190 and they just put it on the page, okay? That's why, so just by looking at this, that line there is 10 megabytes. Okay? Also, which brings up another point which I forgot to mention. When it comes to web performance, a lot of times we're focusing on JavaScript, right? JavaScript bundle and optimize this and minimize that. It's great, but do understand that JavaScript is not your largest resource on the website. It's images and it's videos. Okay, so even if this website has a 2.5 megabyte JavaScript bundle, that's nothing compared to just the 10 megabytes, and then God knows what other images they load, which are larger. Okay, so do take time to optimize these image resources, because loading these, first of all, it's not only you're not only get penalized by Google and cover vitals and search page ranking, but you're also going to frustrate your users. Like I got frustrated just looking at this website. Couple of resources for you. So there's the State of Visual Media report, which is a report from Cloudinary. There's the Web Almanac report, very, very useful to not only to explore media, but other chapters. So that's a link to the media chapter. But as I said, there's JavaScript and HTML and others, and some other links. If you really want to, there's a last link, the Go All In. So at Cloudinary, we have a person, I think he has a PhD, and his job title is Senior Image Researcher. I don't know how many of you heard of the JXL, the JPEG XL image format. He's one of the co-authors. So any blog post, so I link to all his blog posts, any blog post that he writes, like I can't even, quantumization of JPEG, I don't know. Okay, I don't know. But if you're interested in that, he's your guy. He's like amazing. Right. So I think that was it. I'm going to be, wait, thank you. So if you have any questions about any of this or you want to see something, just FYI, I'm not here tomorrow, so today is your chance. So please come talk to me. I'm happy to show you the demos and stuff that I have. Otherwise, that's a link to my page. From there, you can go to Twitter, LinkedIn, etc. So feel free to connect. If you do, just one small thing to ask, if you do connect on LinkedIn, just add the note that, hey, I saw your something, because I get so many requests and I don't know who's who. So just provide me with context. And with that, grazie mille.
Thank you so much. I had a whole list of questions prepared. You already answered all of them. So I hope, do we have time for questions? Oh, one question at least. Yeah, you bring it. Okay.
Okay, thank you. And when you showed your hint to preload an image with link and fetch priority height, how can we deal with this with responsive images? We don't have a source set and so on.
So in that case, you would have to load one image. There's no good answer, because you won't know what to load, right? Unless you can't dynamically build. No, you would have to pick one image that you think is being used most commonly. Also for responsive images, I need to think about it a little bit more. But I don't think there's an easy way to do that. And also, as I said, note that that fetch priority high thing has limited browser support still. And so for other browsers, if anyone else is wondering, so what would you do? You would use just the preload, sorry. So you'd use the preload. That should help. Yeah.
Right, thank you so much.
Thank you.
Give it up for Tamas.